is Sanjay Bale. Me and my group are presenting a presentation of protection of transformer. Content: introduction, protection essential according to the transformer capacity, faults in the transformer, factors to be considered for while designing protection, scheme of transformer, protective devices provided for transformer, differential transformer, fault condition, limitations of planned differential protection, and introduction to microprocessors based transformer protection. So first, introduction. Transformer is a critical in power system. It is involved in transmission distribution stages to alter the voltage level. Power transformer and distribution transformers are involved in different stages of power system. The protection provided depends on capacity of the transformer. Protection essential according to the transformer capacity. First, rating of transformer and their protections. For small distribution transformer, there are fuses on each side. For 500 kVA and above, there are Buchholz relay, earth fault protection over current protection, and etc. And for 5 MVA and above, there are again Buchholz relay, over current protection, differential protection, restricted earth fault protection. Faults in transformer. There are so many faults such as overload, earth faults, through faults, insufficient fault, below oil level resulting into decomposition of oil, and large internal faults such as face to face, face to ground, or below oil level. Factors to be considered while designing protection of scheme of transformer such as transformer KVA rating, voltage and current ratio, type of installation such as indoor and outdoor, fault level at transformer terminals, transformer connection types, percentage reactance of transformer, earth resistance value, neutral point earth resistance value, and cities release connection details.
Protective devices for transformer. Oil level gauge. The gauge gives indication of oil inside transformer tank. If oil level is low, it gives signal to alarm circuit and alarm is sounded to give indication of low oil level. Pressure release valve. Here is the diagram of pressure release valve. The pressure release valve or PRV is designed as a safety device to used on power transformer and similar oil filled electrical equipment. When pressure in tank rises beyond predetermined safe limits, the PRV operates and performs following functions. Reduces the pressure in tank by instantaneously opening the port of 150 diameter in case of T6 models and opening port of 70 mm diameter in case of T3 models. Secondly, along with above mentioned functions, T3 and T6 operators as switch which can be used to initiate precautionary electrical systems, gas actuated relay or Buchholz relay. Buchholz relay. Gas actuated relay is used to detect incipient faults. The Buchholz relay is placed between the main tank and the conservator. Such type of relay is used in transformer having the higher rating than 500 kVA. Fluid temperature indicator. Here is the fluid temperature indicator meter diagram. Temperature sensor is embedded at different locations. This gives oil temperature record, increased temperature of oil in indication of fault in transformer or in cooling systems. Hotspot temperature indicators. Hotspots are formed at winding insulation. Due to stress and failure of insulation, the hotspots are determined by thermography method.
Differential protection. Differential protection is a type of unit protection for a specified zone or piece of equipment. It is based on the fact that it is only in the case of faults internal to the zone, that the differential current that is difference between input and output currents will be high. However, the differential current can sometimes be substantial even without an internal fault. With the exception of the inrush and overexcitation currents, most of the other problems can be solved by the means of the percent differential relay, which adds to the normal differential relay. Two restraining coils fed by the zone through current by proper choice of the resulting percentage differential characteristics and by proper connection of the current transformers on each side of the power transformer. As shown in the figure, the winding of or the part of equipment are to be protected is surrounded by two CTs, CT1 and CT2 for simplicity. Single phase circuit is considered. The current I flows to the winding. The incoming and outgoing current is one and the same. That is, this is valid for normal working condition. The CT secondary carries out the current I1 and I2. These CTs are having the same rating, so the secondary currents I1 and I2 will be equal in normal working conditions. The CT's current polarities are connected such that the current flows in the direction shown. The magnitude are equal. The points A and B are at the same potential, hence no current flows through operating coil of relay. In other words, I1 minus I2 is equal to 0. So differential currents is 0. Fault condition. Consider the ground fault, 0 winding of the winding at point F. The fault current if now flows to ground. CT1 the primary current is I, and for CT2 the primary circuits is I minus IF. Thus primary circuits of CTs are different, hence the secondary currents are also different. I1 and I2 are no longer equal. This also causes potential differences across point A and B. The relay operating coil now carries current I1 minus I2. The relay coil is energized and the relay operates the and operates the relay. It gives trip signal to circuit breaker. The circuit breaker operates and disconnects the winding from system. The scheme thus operates on difference of current principle, hence is called differential protection. Limitation of differential protection. The plot wires are connected in CT secondary circuit. The impedance of pilot wires belong to the CT secondary circuit, hence accurate CT ratio cannot be achieved. CT matching is critical. For large currents in plot wires, the capacitance effect is dominant and may cause maloperation. Introduction to microprocessor based protection. The figure before shows block diagram of microprocessors based on transformer protection scheme. Following parameters are mentioned: temperature of transformer, input voltage, oil level, output current. Above parameters are sensed by appropriate sensors. The sensor output is fed to analog to digital converters. It converts the respective analog signals into digital form. The microprocessors have set reference values stored in the memory. The input voltage, oil level, temperature, output current are continuously monitored. These values can be seen on LCD display which is interfaced with microprocessor. When any parameters exceed the permissible limit or the set reference, the microprocessor sends command to the relay driver circuit. The relay driver circuit operates respective relays R1 or R2 depending upon the command. For example, if overload takes place in the current sensor senses overload conditions and microprocessor then sends command to relay driver circuit. The relay driver circuit operates relay R2. Thus load is disconnected from the transformer. In the similar way, R1 operates for over voltage conditions or excessive temperature rise conditions. Thank you.